Yo, this is Mr. O. Yo, this is Mr. O, and today we're going to learn CPCTC. What CPCTC stands for? It's the stands for the first C is corresponding. Corresponding parts of congruent triangles are congruent. Meaning to say, if our objective is to prove that a corresponding parts of a triangle to be congruent, we must first prove that the two triangles are congruent. So that's why it says here, use CPCTC when asked to prove the parts of the triangle that are congruent. When I mean by parts, it has to be either the sides or the angle, okay? But first, you must prove the triangles to be congruent first before you jump to a conclusion that the specific part has to be congruent. So let's go with the first example here. So given that AB is congruent to AD, that's part of the given. So AB is congruent to AD. And I see BC is congruent to DC. BC is congruent to DC. That's part of the given. BC congruent to DC. There you go. I have two triangles here. The orange triangle and the red triangle here. My goal is to prove that the angle BCA, so this angle here, and DCA, this blue angle here has to be congruent. But in order for me to prove that one, I have to find a way that the two triangles, orange and red, are to be congruent. Looking at the picture, and I've used all the given already there, I know that the orange triangle and red triangle are sharing the same side. So therefore, I know for a fact that AC is congruent to AC. What's the reason there? It's called reflexive property of equality. That means this side is congruent to itself because they're sharing the same side. So now, is this enough for us to say the two triangles are congruent? Yes, triangle ABC is congruent. What's the congruent statement that matches ABC? ABC, so it's going to be ABC, so ADC. Triangle ADC are congruent, ABC and ADC, using side-side congruency. Now, we have proven the two triangles are congruent. Then now we can jump to any of the parts of the orange and the red. The corresponding parts of those will be congruent already using CPCTC, which stands for corresponding parts of congruent triangles are congruent. So here now we can say that BCA is congruent to DCA using CPCTC. Kaboom. Let's go to number 2. Given that PS and QR are parallel, we know when we're given a hint of PS and QR parallel, we probably gonna use the theorem of the alternate interior, alternate exterior, corresponding, and so on and so forth. Okay, and we have already also here QPS is congruent to SRQ. So let's put that one in our statement and write the reason there given. And let's see, where's PS? PS is right here. Remember what we can extend this one so we can see it better, what it looks like, and QR is right here. And we know that this could be our transversal line. So now we can see that PSQ, this angle here, and RQS are going to be congruent using alternate interior angle. So let me write down here that angle PSQ is congruent to angle RQS. Okay, using alternate interior angle theorem. Okay, and part of the given is saying that QPS, so this angle here is congruent to SRQ. So this angle here. So I have here an angle and an angle, having an angle and an angle. So we need one more. Again, look at the two triangles here. See the blue triangle and the red triangle? Do they share the same side? Yes. The share side at this side here, right? So we know that side QS is congruent to, take note, QS. And look at the pattern. That's QS, the first and the third letter. So here is going to be SQ. And same segment, share same side, that will be reflexive property of equality. Now we can say that we have a side here and a side here. So we can say that two triangles QPS is congruent with triangle SRQ using AAS. Now, after that reason and statement, that line, we have proven that the blue and red triangle are congruent. Now we can say that the corresponding parts and the other parts of the triangle are congruent. So we're trying to prove that PQ and RS are congruent using CPCTC. Kaboom. Very easy, right? One more. So here, given X is the midpoint of WY and VZ, prove that angle XWV is congruent to XYZ. So let's look at the given. So let me write the statement and the given there. And I know that's what I'm trying to prove. I know that X is the midpoint of WY. So this side here and that side are going to be congruent. And X is also the midpoint of VZ. So these two here are congruent. Okay. So we can say now that WX is congruent with WX will be congruent to YX because definition of midpoint. Likewise, on the orange one, we can say that VX is congruent with ZX definition of midpoint. Now we have proven that. Let's look at the other. We have used the given. Let's look at the picture. As I can see, I have a vertical angle here. So I know that angle WXV is congruent with angle, what's a part of W? Part of W is Y. YXZ. How do you know it's Y, the part of W? Because W second letter here is Y. And also you can see that this W, there's a wider partner, and the part of V is Z there. Okay. And what's the reason for that? That's going to be a vertical angle theorem. Okay. So now we can say we have a side and an angle and a side here, a side and an angle and a side here. We can say triangle WXV is congruent to triangle YXZ using side angle side. At this point, we have proven that the two triangles are congruent. Then the corresponding parts of these two congruent triangles are going to be congruent. I can say that this side here is congruent to that side. I can say this angle here is congruent to that angle, and also with Z and the V there. But we're trying to prove that angle XWV is congruent to XYZ using CPCTC. Okay? And there you have it. And that's how you use the CPCTC, or the corresponding parts of congruent triangles are congruent. And as always, kaboom.